When you turn on the tap in a cruise ship bathroom, the water flows exactly like it does at home. You can take a 20-minute hot shower or swim in a massive glass-bottomed pool on the top deck. It feels like unlimited abundance. But underneath that experience is a massive logistical paradox. A modern mega cruise ship is an isolated floating city. Between the passengers, crew, kitchens, and laundry facilities, up to 8,000 people consume over 500,000 gallons of fresh water every single day. If the ship relied strictly on what it could carry in its storage tanks, it would run completely dry in about 72 hours. Running out of water means the massive engines cannot be cooled, and food can no longer be prepared safely. Thousands of toilets would instantly stop flushing. Within hours, the vessel would experience a catastrophic sanitary collapse, turning a luxury environment into a massive biological hazard. Preventing this failure requires the ship to operate as a heavy-duty municipal utility plant, aggressively manufacturing its own survival out of a hostile saltwater environment. Attempting to bypass this engineering by filling massive holding tanks at the port of departure fails against the brutal physics of weight. This data visualization shows the scale of the problem. At 500,000 gallons a day for a standard 7-day voyage, the ship would need to carry 3.5 million gallons of water, weighing nearly 30 million pounds. Holding tanks of this scale would leave almost no room in the hull for engines, fuel, or passengers. Furthermore, adding 30 million pounds causes the ship to sit dangerously low in the water, creating severe hydrodynamic drag that forces the engines to burn exponentially more fuel. The physics of displacement makes storage impossible. The ship must continuously manufacture its own survival while in motion. Deep in the dark, restricted lower decks, the ship relies on enormous engines that generate a colossal amount of waste heat. Boiling raw seawater at standard atmospheric pressure takes 212 degrees Fahrenheit. Attempting this on the ship would be a catastrophic waste of fuel. To lower the energy threshold, engineers route the engine cooling water into a specialized vacuum chamber. Inside, massive ejector pumps suck the air out, dropping the atmospheric pressure inside. In this vacuum, the boiling point of water plummets to just 104 degrees Fahrenheit. The leftover engine heat is enough to flash the salt water into pure vapor. The heavy salt and minerals sink to the bottom as brine, while the pure steam rises to hit cold pipes and condense into liquid water. By harvesting this waste heat, the ship uses the physical act of moving to manufacture its own drinking water in a self-sustaining loop. Flash evaporation is efficient, but demand spikes every morning when thousands of passengers wake up and shower between 8 and 10 a.m. The engine heat cannot boil water fast enough to keep up. When demand outpaces the evaporators, the ship triggers its reverse osmosis plant. This system relies on brute physical force, using massive industrial pumps to ramp up the pressure to over 1,000 pounds per square inch. Under this crushing pressure, the salt water is slammed against tightly wound polymer membranes. The microscopic pores are so small that only tiny H2O molecules can squeeze through, while larger salt molecules and bacteria are physically blocked and flushed away. To manage the massive electrical load, an energy recovery device routes the high-pressure wastewater through a mechanical turbine. The pressure of the outgoing water spins a rotor that helps power the incoming pumps, recovering up to 60% of the energy. When thermodynamic efficiency reaches its limit, the ship relies on this high-energy physical force to meet the scale of human consumption. Between the evaporators and the reverse osmosis plant, the ship manufactures hundreds of thousands of gallons of pure water. But pumping this water directly into passenger cabins would trigger a separate disaster. In its perfectly pure state, H2O acts as an aggressive solvent. It is chemically hungry and will actively leach ions and minerals out of the ship's copper and steel plumbing, eating through the pipes from the inside out. This chemical flow diagram shows the remineralization process. Pure water is forced through beds of crushed limestone and injected with carbon dioxide to absorb calcium and magnesium. This neutralizes the acidity and gives the water a crisp taste before it is hit with ultraviolet light to destroy any remaining bacteria. This chemical re-engineering is a requirement for survival, protecting the ship's heavy infrastructure from being devoured from the inside out. The ship now has a massive supply of safe water in storage tanks on Deck 1 at the very bottom of the vessel. But pushing millions of pounds of water up to Deck 16 requires fighting relentless gravity. A single giant pump would create a pressure gradient disaster. Pressurizing the water enough to reach the top deck creates such extreme pressure on Deck 2 that it would blow the shower heads right off the walls. This vertical cross-section shows the ship divided into horizontal pressure zones. Intermediate tanks maintain steady flow, while hidden valves mechanically choke water based on deck height to equalize pressure. To prevent stagnant water breeding bacteria, the plumbing forms a continuous loop. Unused water reaching the end of a corridor cycles back to the engine room for sterilization. The luxurious experience of a hot shower is the final result of mathematically fighting gravity and strictly choking water pressure across a massive steel grid. The system continues even after the water goes down the drain. On a ship, the constant pitch and roll of the ocean renders standard gravity-based plumbing entirely useless. Instead, the ship uses a centralized vacuum. This system violently sucks wastewater through the pipes at up to 40 miles per hour, using only a tiny fraction of a gallon of water per flush. All gray and black water is routed to an advanced wastewater purification system. Inside massive membrane bioreactors, specialized cultures of bacteria consume the organic waste. After pushing liquid through fine filters to remove microplastics and blasting it with ultraviolet light, the final water discharge is chemically cleaner than the raw ocean water the ship had originally pulled in. The illusion of an endless tap is bought with intense mechanical violence, high pressure, and the precise chemical engineering required to sustain a floating city on the high seas.